Algebraic formulas. In this video lecture, we're going to talk about algebraic formulas and our objective. Use algebraic formulas to solve application problems. All right, so first things first, let's do a definition. What's a formula? A formula is a set of symbols that expresses a mathematical fact or rule. In general, the right side of a formula is an algebraic expression, which we discussed in a previous video lecture, that can be evaluated. Okay, let's take a look at some examples of formulas. Okay, how about this one? A equals L times W. Many of you will notice that this is the formula for the area of a rectangle. Area equals length times width. Area of a rectangle. All right, another formula. How about C is equal to 2 pi r? 2 times pi times r. And again, most of you will recognize this is the formula for the circumference, if I can spell circumference, of a circle. And I'll give you one more. How about I equals PRT? Not nearly as popular as these first two. This is the interest is equal to the principal times the rate times the time. This is the formula for simple interest. It's the formula that banks and other financial institutions use. Okay, so we want to use formulas and to use formulas to solve application problems. Let's take a look at some. We've just got a couple of quick examples here. Example 1. The formula for converting degrees Celsius to degrees Fahrenheit is F equals 9/5 times C plus 32. C, of course, stands for degrees Celsius, and F stands for degrees Fahrenheit. So, if you're in Europe, of course, is metric, and so they're going to tell you the temperature degrees Celsius, and you're told the temperature outside is 25 degrees Celsius. Well, in America, that's mighty cold. But America, we use Fahrenheit. So what is the equivalent temperature in degrees Fahrenheit? Well, what this is asking us to do is the Fahrenheit. I'm going to recopy the formula. 9/5 times C plus 32. We want to use this formula for Celsius equals 25. Okay? As I mentioned in the previous video lecture, it's very important to first copy and substitute. You're going to evaluate the right side. So first replace the letter, in this case the C, with parentheses. So you can keep things straight, and it makes things rather simple with a calculator, so there's no mess up with the order of operations. Now we can replace the C with 25, put it right inside here, and now we've got a calculator problem. So I'll go to my, in this case, a T84. Okay, I'll use that fraction bar just so we see 9/5 clearly. 9/5, open parenthesis, 25, close parenthesis, come up a little bit here, plus 32, enter. And it looks like the temperature, the 25 degrees temperature in Celsius is equivalent to 77 degrees Fahrenheit. So in Fahrenheit, we have 77 degrees, which is that's a pretty delightful day. Maybe a little warm for some, but actually a pretty nice day for most people. Okay, second example, a second and final example for using formulas. The mathematical model, P is equal to negative 0.01 s squared plus 0.8 times s plus 3.7 describes the percentage of college students, P, who anticipate a starting salary S in thousands of dollars. Use the formula to find the percentage of students who anticipated a starting salary of $30,000. Now, the S is in thousands, So all I need is the 30 because it's 30,000. So let's copy the formula. P is equal to negative 0.01 times S squared plus 0.08 times S plus 3.7. And we want to evaluate this formula. We want to use this formula for when S is equal to 30,000. And since thousands is specified here that S is in thousands, we just need the 30. Okay, as I said before, let's first, before we evaluate the right side of this formula, let's copy it and let's replace all the S's, all the variables with parentheses so that we don't lose track of what's going on with the order of operations. Now we can put the 30 inside the parentheses, and this just became, again, a calculator problem. I'm going to slide it up a little bit, put my calculator right down here. I don't need to go any further by hand. So negative 0.01, open parenthesis, never mind, 30 squared, plus 0.8 times 30, open close parentheses, plus 3.7, and I come up with 18.7%. So the percentage is 18.7%. Again, P is let's come down a little bit here. P is the percentage, so I already have the percentage. No reason to do any more math or any playing with that number. So 18.7% is the percentage of students who anticipated a salary of $30,000. So there you have it. Again, I'll emphasize, as I did in a previous video lecture, the importance, copy the formula down, show your work, replace your letter with parentheses because it makes it much easier to follow through correctly with the math. Okay?